Okay, here's the second nice triangle that leads us to the 6 trig functions of 2 different angles. We get double the value out of this one. This time I'm going to start with, as best I can draw it here, an equilateral triangle. Okay, I want this to have all 3 sides the same length, and so all the angles are the same. The angles have to add up to 180 degrees, so if you take 180 divided by 3, that would be 60 degrees. Each angle here is a 60-degree angle. Right. Now I'm going to give the sides a certain length, and I'm going to use 2 because of what I'm about to do next. What I'm going to do next is I'm going to take an angle bisector here, which is also an altitude, which is also a median, and drop it down through the middle there. This, in an equilateral triangle, this line here, perpendicular, serves 3 purposes. 1, it's perpendicular. 2, it bisects the side over here. So this has length 1 and this has length 1. It also bisects the angle up here. So those 2 are the same. So now if I just look at 1/2 of that triangle, so I want to just grab half of that triangle. The right angle's here. This hypotenuse here is the original side length of the equilateral triangle. The short side down here is the half of that, so 1. I can use Pythagoras to find this side over here. It's got to be the square root of 2 squared minus 1 squared, which is the square root of 3. So this side is the square root of 3. This angle is still 60 degrees. This angle up here now is half of that 60-degree angle that was there, so this is 30 degrees. Okay. So I've got a 30, 60, 90 triangle. 30 degrees, 60 degrees, 90. Notice that the smallest angle is 30 and the smallest side is 1. The biggest angle is 60. No, it's not. The biggest angle is 90 and the biggest side is 2. This is one source of error I had when I was first learning this, is that for some reason I always wanted the radical on the hypotenuse. I wasn't even thinking until one day it occurred to me that the hypotenuse has to be the biggest side, and 2 happens to be the square root of 4, which is bigger than the square root of 3. Okay. Square root of 3, by the way, you should think George Washington, because the square root of 3 is, at least to 3 decimal places, is 1.732. George Washington was born in 1732. Anyway, a little history lesson to go with your math here. But this is a great triangle now because I can see 6 trig functions of 2 different angles. For instance, I can see that the sine of 30 degrees is the opposite over the hypotenuse, is 1 over 2. The cosine of 30 degrees is the adjacent over the hypotenuse, radical 3 over 2. The tangent of 30 degrees, let's slide this up a little bit, the tangent of 30 degrees is opposite over adjacent. It's 1 over radical 3, and just like in the previous video, I would leave that this way. I think that's more simple than rationalizing the denominator. Cotangent of 30 degrees, and here's one reason it's more simpler, yeah. Take the reciprocal, it's radical 3 over 1. It's already in simplified form. You don't have to cancel something out because you hadn't complicated this ahead of time. Anyway, that's the square root of 3. Next is the secant of 30 degrees. The secant of 30 degrees is the hypotenuse over the adjacent side. So 2 over the square root of 3. Again, don't worry about rationalizing. And the cosecant of 30 degrees is hypotenuse over the opposite side, 2 over 1, which is just 2. Okay, we got all that information, plus we get the same information about 60 degrees. What's the sine of 60 degrees? Well, now I'm focusing on this angle. Opposite over hypotenuse is the square root of 3 over 2. What's the cosine of 60 degrees? That would be the adjacent over the hypotenuse, 1 over 2, which is commonly called a half. The tangent of 30 degrees is the, sorry, I'm working on 60 degrees. The tangent of 60 degrees is the opposite over the hypotenuse. radical 3 over 1, which I might as well just write as radical 3. The cotangent of 60 degrees would be the reciprocal of the tangent, so 1 over radical 3. Leave it like that. The secant of 60 degrees is 2 over 1, the reciprocal of cosine, which is just 2. And the cosecant of 60 degrees is the reciprocal of the sine, so 2 over radical 3. Right. 6 trig functions for 30 degrees, 6 trig functions for 60 degrees. Do I expect that you have those memorized? Absolutely not. Do I expect that within maybe 3 seconds you could figure out any one of these things? Yeah, I think so. Refer to the picture. I do not have these memorized. I've been teaching this stuff for 30 years now. 30 years? Well, maybe I've only been teaching for 20 years, but I've known it for 30 years. I don't have it memorized. I have this triangle here. If I can't remember that triangle, I say, oh yeah, it came from cutting this one in half, and it gets me all the pieces very quickly. Once I've got all the pieces, I can see each of those trig functions. I know what 2 sides I need for each one of those. And it's the same 2 sides for sine, no matter whether it's a 60-degree angle or a 30-degree angle. It's the opposite over hypotenuse. So I've got a small amount of things remembered, which allow me to come up with a lot of different results. Right? There you go. There's our other 2 nice angles.